So this is student workbook 1B, position and velocity. They say Angela here is running at 3 meters per second towards the bus, which is 15 meters away. And they say create a motion map. That's a dot diagram. And so that's basically showing where she is every second. So she starts here at 0, and then 1, 2, 3. She winds up at the third spot here after 1 second. And then 1, 2, 3 out there at 6 meters, and then 1, 2, 3 at 9 meters, and then 1, 2, 3 at 12 meters, and then 1, 2, 3 up to 15 to where the bus is. So this is where she would be if you took a strobe photography, say, every second of where she was. The table here, you'd probably be able to recognize the pattern even if you didn't see what they were. These are going up by 1s, these are going up by 3s. So 0, 3, 6 meters, and then the next would be 9 meters, and then 12 meters, and then 15 meters. You don't need to put meters in every box, by the way, if the meter is already over there at the beginning of the table. So next thing they want us to do is to draw a graph from this data. So let's put this off to the side for now. Put the graph back on here. It is a position versus time graph, since position's on the y and time is on the x. So let's plot our data points. Our first one was 0, 0. At 1 second, we were at 3 meters. At 2 seconds, we were at 6 meters. At 3 seconds, we were at 9 meters. At 4 seconds, we were at 12 meters. And at 5 seconds, we were at 15 meters. So it says get a straight edge and draw a line of best fit. And I don't have a straight edge right here on me, so I'm going to use a book, which is a generally bad practice. Don't use your book as a straight edge, you'll leave a mark. But all right, so right here. All right, so there's our line of best fit, and it's a perfect line of best fit because they gave us perfect data here. So now they want you to calculate the slope, get the rise over the run for this. So just in case you don't know, they spell it out for you there. Rise over run, which is the slope, is technically your second y value minus your first y value divided by your second x value over minus your first x value. In our case here, they say to pick 2 points. We're going to go ahead and practice using points. You can use whatever on here. They say, remember, use points not on not your data points, but on the line. But in this case, they're the same. But again, if it was sort of staggered around here, you would have to make sure you're using data points on the line itself and not just from the data points. Just to make it a little bit different, I'm going to use this one right here and this one right here, just to make it a bit more mathematically challenging, just to get the point. All right, so in this case here, our y value is 15. You can consider that like our final position, and our initial position there would be 6. And then our final time here would be 5. That's our final x position. And our initial x position would be 2. And so when we go to solve for these, 15 minus 6 is 9. 5 minus 2 is 3. Simplify 3 meters per second, which we already knew, right? They told us that from the beginning, but it should match up in that case. So now let's get to the bottom part there where they say, what does the slope represent? We know that. We've gone over it in class. The slope represents the physical quantity velocity. And so, in other words, you can say speed for now, but we'll get to velocity is a better way to say it going forward. So one last thing here is they tell you about writing the equation for a line. So in general, y equals mx plus b is the equation for a line. But let's pull our graph back here. What do these represent? Well, the y-axis is position in this case. So I'm going to substitute x, not x for x-axis, but x as in position here. And then they tell you they actually want a number for the slope. We found the slope right here, remember, it's 3 meters per second. So I'm going to write that in there with the units. And then they say write another letter. Well, the x-axis, that's what that stands for, but in this case, our x-axis is time. So I'm gonna write a t for time, and then plus b. Well, what's b? b is the y-intercept. You can see that it's 0, so we won't write anything. But just to drive the point home, what does it mean where it intercepts the y-axis? Let's say we had started our line here. Well, then that y-intercept is our initial position. So we could have started at 5 meters. We could have set the problem up like that. But it's kind of doesn't matter in this case because there is no value there. So we can say, now we have like an equation that we've made up. Our position is 3 meters per second times however many seconds that we're talking about. If we wanted to make it more general, we could say x equals, and a letter for this would be v for velocity times t. So using our graph, we have basically made an equation. We can predict the position at any time because we know the value of our velocity.